Chapter 7, Chemical Kinetic. What is the difference between thermodynamics and kinetics? In the previous chapters, we studied the thermodynamics, the thermochemistry, where we calculated delta H of a transformation and the meaning of delta H according to the sign delta H negative or delta H positive, so exothermic or endothermic. Then we passed to the second law of thermodynamics and we defined the entropy delta S, and we have a conditions delta S of the universe positive, so the transformation is spontaneous. Then we transformed delta S of the universe to delta G of the transformation, and if delta G is negative, our transformation is spontaneous. So the objective of the chemical thermodynamics is the prediction if a chemical reaction occurs spontaneous or non-spontaneous, or in other words, if a chemical reaction is possible or impossible at certain given conditions. The chemical kinetic is the study of the rate of the reaction. But to study the kinetic of any reaction, the reaction should start. So when the reaction starts, the chemical kinetic indicates what is the rate of this reaction, or how fast does the reaction proceeds, and how far will this reaction go before it stops. So the thermodynamics talk about reaction spontaneous or non-spontaneous. If we discover by thermodynamics that this reaction is spontaneous, we can pass to the study of the chemical kinetic. So the chemical kinetic is the branch of chemistry which is concerned with the rates of the chemical reaction and the mechanisms by which they take place. In the chemical kinetic, we define the speed of chemical reaction, and it's measured as the change of the amount of reactants or products per unit time. Suppose we have the reaction H2 gas plus I2 gas that give 2HI gas. We can study the rate of this reaction by measuring the rate of disappearance of hydrogen gas, or the rate of disappearance of I2 gas, or the rate of the formation of HI gas. Then we can deduce the rate of the reaction at any time, because we have a relation between the rate of reaction, the rate of disappearance, and the rate of formation. In the chemical kinetic, we have a classification of reactions. Some reactions are fast. They end by few seconds. For example, the reaction between H2 and O2 gas to give H2O. We have slow reactions. It took few minutes. For example, the oxidation of iron solid to FeO, and other reactions, the third type, reactions very slow. For example, the transformation of carbon diamond to carbon graphite. So we have three types of reactions: fast, slow, and very slow. In grade 12 in college, you studied the kinetic of the reaction, and you did experiments in order to find this kinetic. So if the reaction, for example, we mix A and B, then after 1 minute, we take certain amount of the solution, we put it in ice bath water mixture or at temperature very low in order to stop the reaction. Then we do titration. Okay, so all reactions practically, to study the kinetic of a reaction, the reaction should not be fast. If this reaction is fast, we could not study its kinetic. So most of the reactions studied are slow reactions or very slow. We have two types of reactions. We have a reaction which is complete. That means this reaction proceeds till T equal infinity, and the change in amount or concentration per unit time, we calculate the change in amount or concentration per unit time, and this reaction is in one direction. Some reactions took place in two directions, and you call this reaction reversible. We know that the term reversible means reaction or transformation in two directions, but these conditions in direction 1 and direction 2 are the same. So this reaction in double direction is reaction taking place at different conditions in direction 1 than in direction 2. So I prefer to call it reaction in two directions. In each direction, the forward or the backward, we can study the kinetic of the reaction. We can study the kinetic in direction 1 or the kinetic in direction 2, and the kinetic is different since at T equals 0 we have reactants and the products 0. So the rate of the reaction in direction 1 is maximum, that will decrease with time due to the decrease of the quantity of reactants. In the products, at T equals 0, we have 0 products, and the quantity of the products will increase with time. So the rate in direction 2 will increase. Rate in direction 1 decrease. At the same time, rate in direction 2 increase. At a certain time, the rate in direction 1 is equal to the rate in direction 2. So the two rates are equal. We define the equilibrium state. We say that our reaction is at equilibrium. The equilibrium does not mean that the reaction is at the end. The equilibrium is the coma state of the reaction. So this reaction will proceed in the two directions, but the rate in direction 1 is equal to the rate in direction 2. We could not observe at equilibrium the change in the concentration of reactants and the product. So the concentration of the reactants and the concentration of the products at equilibrium are constant. For this reason, we define what we call the equilibrium constant, which is equal to the products divided by the reactants according to the stoichiometry, and we call it equilibrium constant. We define the term constant since in the solution, for example, the concentration of the reactants and those of products are constant at equilibrium. So the rate of the chemical reaction is measured in terms of how much the concentration of the reactant decrease in a given period. So the rate of the reaction is studied according to the rate of disappearance of reactant, or the rate is studied according to the product concentration that increase with time. So it's studied according to the rate of formation. To study the rate of the reaction, we can use rate of disappearance of reactant, of rate of formation of product. Pay attention that for reactants, a negative sign is placed in front of the definition. The negative sign is in the definition, but the value of the rate is always positive. For a reaction from A to B, the instantaneous rate of disappearance of A is given by the relation R equal minus the variation of the concentration per time, so minus dA divided by dt at time t, and the rate of formation of product B is given by Rb at time t is equal to plus dB or dt. The rate can be defined by the variation of the number of moles per time. But in solution, since the volume is constant, we prefer to use the term variation of the concentration per time. So pay attention, the negative sign is in the formula of the rate, but the value of the rate is always positive. We could not have a negative value for the rate of disappearance. So when the reaction proceeds, the concentration of A decreases with time, that of B increases with time. And since the concentration is a kinetic factor, so the rate of the reaction, the rate of disappearance, will decrease with time due to the decrease of the reactants per time. So the rate of the reaction, pay attention for this point. The rate in general decrease with time. In this course, this year, we will prove that the rate may be constant. So the rate of the reaction decrease in general with time. This is the concept you studied in grade 12. This year, we will study that some reactions have rate constant, but never the rate of the reaction increase with time. The rate decrease or the rate may be constant, but never the rate increase. Rate calculation. I give till now only the definitions, the notations. I will explain later what is the objective of the chemical kinetic chapter. So how to write or how to find the rate of disappearance or the rate of formation or the rate of the reaction. In general, when you study the rate of the reaction, you do a table, the variation of the concentration of reactants per time. So you study the rate of disappearance, or you do a table, the rate of formation, the concentration of the product formed per time. So you studied the rate of formation. Suppose I have the reaction H2 plus I2 gas that give 2HI gas. The concentration of H2 will decrease with time. The concentration of I2 will decrease with time. And the concentration of HI will increase with time. So the variation of the concentration of H2 per time is a decreasing curve. That of HI per time is an increasing curve. So at t equals 0, this value with the y-axis is the concentration of H2 initial that will decrease till this value, which is, for example, the H2, the concentration of H2 at t equal infinity, at t final. How to find the rate? At any point of the curve, you make a tangent to the curve. The tangent of the curve for the rate of disappearance. The negative slope of the tangent is the rate of disappearance at this point. Suppose you studied the rate of formation at a certain time, you make the tangent, the slope of the tangent at this time is the rate of formation. So the rate of disappearance or the rate of formation at a certain time t is obtained by making the tangent at time t to the curve of variation concentration equal ft. What is the difference between the instantaneous rate and the average rate? The instantaneous rate is the rate at determined temp, at determined time. The average rate is the change in the measured concentration, or is the variation of the concentration per period, per time period. So the average rate is given between two instants, T1 and T2. The instantaneous rate is at instant T. The larger the time interval, the more the average rate deviates from the instantaneous rate. What is the meaning of this statement? The average rate at the beginning, the average rate will be close to the instantaneous rate. As you increase the interval of time, you will observe that the average rate deviates from the instantaneous rate at time t. Relation between the instantaneous rate of disappearance, the rate of formation, and the rate of reaction. Consider the general reaction AA plus BB that gave CC plus DD. In the chemical kinetic, the stoichiometric coefficients A, B, C, and D are very important. The rate of the reaction is related to the rate of disappearance of reactants and the rate of formation of products according to the stoichiometry. So the rate of the reaction equal RA divided by A equal RB divided by B equal RC divided by C equal RD divided by D. But pay attention, when using this relation, it should be at the same time t. For example, R at 5 minutes, the rate of the reaction at 5 minutes equal the rate of disappearance of A at 5 minutes divided by A equal the rate of disappearance of B at 5 minutes divided by B equal the rate of formation of C at 5 minutes divided by C. So when using this relation, pay attention, all rates should be at the same time. Also, the rate of disappearance is related to the rate, the average rate of the reaction is related to the average rate of disappearance or the average rate of formation according to the stoichiometry. And pay attention, this relation can be applied at the same delta T. R bar, I use R bar. This is the term for the average rate. R is the term for the instantaneous rate. Consider the reaction to H2O2 to 2H2O plus O2. What is the relation between the rate of disappearance or the rate of formation? The rate of the reaction equal RH2O2 divided by 2 equal RH2O divided by 2 equal RO2 divided by 1. Or you can write the rate of the average rate of the reaction, R bar of the reaction equal R bar of H2O2 divided by 2 equal R bar H2O divided by 2 equal R bar of O2 divided by 1. Pay attention at the same interval of delta T. Example 7.1. For the reaction given, the concentration I minus changed from 1 molar to 0.868 molar in the first 10 seconds. So at t equals 0, I have 1 molar I minus. At t equals 10 seconds, the concentration equals 0.86 molar. Calculate the average rate of the first 10 minutes and the delta H plus. Okay, we apply the rate of the reaction. We apply the relation. The average rate of the reaction is related to the average rate of H2O2 divided by 1 equal average rate of I minus divided by 3 equal average rate of H plus divided by 2 equal average rate of I3 minus divided by 1 equal average rate of H2O divided by 2. We can calculate the average rate of I minus for delta T equal 10 seconds, which is equal 0.868 minus 1 divided by 10, and the rate of the reaction equal the average rate of I minus, which is minus delta I minus divided by delta T. This is the average rate of I minus divided by the stoichiometry 3, so we obtain the rate, the average rate of the reaction for delta T equal 10 seconds. And the same for delta H plus. What are the factors that affect the rate of a reaction? First, the temperature. In grade 12, you studied that the temperature is a kinetic factor. When the temperature increases, the rate of the reaction increase. So what is the reason for this process? When we increase the temperature, the reactants will absorb energy as kinetic energy. So the reactant will move faster. Therefore, we will have a greater collision between the reactants, and the rate of the reactant and the rate of the reaction increase. So when temperature increase, the rate of the reaction increase is based on two theories. The first is the collision theory, and the second is the kinetic theory. In the collision theory, when two chemicals react, their molecules have to collide in a particular orientation with certain energy for the reaction to take place. Sometimes we say the reaction between A and B did not occur. Why? Because A and B did not have collisions to proceed this reaction. When the temperature increases, the probability of collision between A and B increase, so the probability of the reaction increase, and therefore the rate of the reaction will increase. The kinetic theory, increasing the temperature, means the molecule will absorb energy, so these molecules will move faster. So as a conclusion, when the temperature increases, the rate of the reaction increase. Pay attention, the temperature and the rate are related by the same order. As T increase, rate increase. Do not confuse between capital K and the small k. Small k is related to the rate of the reaction, and I will explain later what is the rate constant. But capital K, the equilibrium constant, depends also on the temperature, but the equilibrium constant may increase or decrease with the temperature according to the nature, to the thermodynamic nature of the reaction. The second factor is the concentration of the reactants. You studied also in the kinetic in college that increasing the concentration of the reactants will increase the rate of the reaction. Also why? When you increase the concentration of reactants, you increase the probability of collision between these particles or these molecules. And therefore, the rate of the reaction will increase. The factor number 3 that affect the rate of the reaction is the catalyst. We will study in details what is the meaning of the catalyst and what is the mechanism of a catalyst. A catalyst will speed a spontaneous reaction. When the reaction is spontaneous, adding catalyst will increase its rate. And how the rate increase? By lowering what we call the activation energy that should be explained later. The factor number 4 is the surface area of a solid reactant. When you increase the surface area for reactants, so this reactants, the probability of collision between these reactants will increase. So the rate of the reaction increase. And the factor number 5, suppose in your reaction you have gas, a reactants or a product. So when you increase the pressure for gases, you increase the number of collisions and therefore the rate of the reaction will increase. So as a conclusion, the temperature that affect the rate of the reaction, the factors that affect the rate of the reaction are T increase, rate increase. Initial concentration of the reactants increase, rate increase. Adding catalyst, rate increase. Increasing the surface area of reactants will increase the rate. And if you have gases in your reaction, increasing the pressure will increase the rate of the reaction. So what are the main objectives of the chemical kinetic? In the previous slides, I gave only notations and definitions. Now we will start the chapter. What are the objectives of the chemical kinetic? First, the reaction rate, the rate of the reaction. So we have to know how to measure the rates. I explained that we draw the variation of the concentration as a function of time. Then on the curve at time t, we make a tangent. The slope of the tangent is related to the rate of disappearance. The negative slope of the tangent is the rate of disappearance at time t. The positive slope of the tangent is the rate of formation at time t. So this objective is well studied in grade 12. The main objective of the chemical kinetic is to write what we call the rate law, is to find the expression called rate law expression that relate the rate of the reaction to the previous factors that affect this rate, the temperature, the concentrations, the catalyst, the surface area, the pressure. So this is the main objective of this course, is to find what is the expression of the rate law, or in other words, what is the relation between the rate of the reaction and the factors that affect this rate at given time t. The objective number 3 is to write what we call the integrated rate law. The integrated rate law means how to calculate the amount remained or the time to reach a given amount. For example, consider a reaction. We start at t equals 0 by reactant A and reactant B of known concentration or known number of moles. And the quantity of product equals 0. So the question, for example, what would be the concentration of the reactant A after 50 minutes or after 5 minutes? Or what is the amount of B that formed after 10 minutes? To solve this type of the exercises, we have to pass by the integrated rate law that gave the relation between the concentration and time. Objective number 4 is the half-life or the half-time T-half. How long it takes to react 50% of reactant, or how long it takes to form 50% of the final products. So the objective number 4 is to calculate what we call T-half. Objective number 5 is the use of Arrhenius equation. We know that the temperature affects the rate of the reaction, or in other words, the rate of the reaction is related to the temperature, or the rate constant is related to the temperature. So the rate of the reaction at 5 minutes is the following. Suppose you repeat this reaction at temperature greater. You start the first experiment at 25. You repeat this reaction at 50. He can ask, for example, for the reaction at 50, the rate is greater than the reaction at 25. For the same time, for example, at 5 minutes, calculate the rate of the reaction. The rate of the reaction realized at 50 degree. So this is the relation between the rate constant or the rate of the reaction as a function of the temperature, and this relation is given by the Arrhenius equation. The objective number 5 is the mechanism. What is the mechanism of a reaction? When you studied a chemical reaction, you know the nature of your reactants, and you know the nature of the products formed, but you don't know the pathway of the reaction, how this reaction was realized. So the mechanism will give the steps of the reactions between the initial reactants and the final product.